All right, welcome everybody. We're going to do lesson 15, structure and graphs of polynomial functions. So this lesson will be extremely important to understand this concept of end behavior. So two things. Make sure you're on lesson 15 and make sure you have this paper that I'm giving out in class. So let's look at this page first. Here, it's saying that if I have, let's get the camera all going. Let's say if I have this f of x function, it's equal to x squared. What will this graph look like? What will x to the fourth look like? What will x to the sixth look like? Okay? What I want you to do is take your calculator and graph each of these: x squared, x to the fourth, x to the sixth. And then I also want you to graph negative x squared, negative x fourth, negative x to the sixth. Do the same thing for the others: x to the third, x to the fifth, x to the seventh, and these as well. All right? Take your time, pause the video, and graph them with your calculator. And I'll pause the video. X to the fourth, x to the sixth. Notice that the graph gets wider, right? But the arrows still stay the same. And these arrows will be very important when we talk about end behavior. Here, negative x squared, what happened? It just flipped. X to the third, x to the fifth, x to the seventh. Notice it gets wider. And then here, what's the dance move? Like this is x cubed. Negative x cubed, what happens with your dance move? Your hands go the other way, right? And we're talking about this. So here, what I want you to do is have the colors and make sure you're nice and color coordinated for today. And we'll talk about this. Here, it's talking about the degree of the polynomial. Here, if I have x squared, x to the fourth, x to the sixth, here, my degree is even. These are even numbers. And if the degree of any polynomial is even, the end behavior will be the same. Okay, so let me write that down. If the degree of any polynomial is even, and notice that the coefficient, the leading coefficient is positive, the end behavior will have this. Okay, and what do I mean by end behavior? End behavior, now this notation may look a little freaky at first, but don't freak out. Here it's saying that as x approaches negative infinity, f of x approaches positive infinity. Okay? As x approaches positive infinity, here my f of x approaches positive infinity. Okay. Now this, if you're looking at this, you're probably thinking, what on earth are you talking about, Mr. G? And then we'll focus on this right now. So let me make sure this is good. Here, let's look at the graph. If we start here, we're 0. Okay, so this is 0. Right? This is 0, 0. Now, imagine your x value, right? What's my x value here? Negative 1, negative 2, negative 3. But you go to negative infinity, right? And as your x value goes to negative infinity, what's happening to your f of x value? This is your y. This is going to 1, 2, 3. It's going to positive infinity. And this is what this is talking about. Let's look here. As x goes negative infinity, f of x goes up to positive infinity. Let's look at the next one. You see, as x goes positive infinity, you see, if I'm 1, 2, 3, if I keep going to positive infinity this way, what happens to my f of x value? Do I go up or I go down? I'm going up to positive infinity. And this is what the end behavior is talking about. It's saying that if I have any even degree polynomial, this will always happen. Okay? What I want you to do is try and fill out the rest over here using this notation. And if you want to work it with me, we'll do it together. If we look at this one, this will be odd. And what's the leading coefficient? It's positive, right? And this has to do with these, right? Notice that 3, 5, 7, these are odd numbers. And the leading coefficient is positive. So here, let's talk about end behavior. What I want you to do is, the most important part is, try and figure this out, okay? As x approaches negative infinity, what happens to the f of x? As x approaches positive infinity, what happens with the f of x? Okay, so here I want you to pause the video and try and figure this out right now. Where does f of x go? All right. Here, let's take a look. You see, as x is going to negative infinity, right? As I'm going this way, am I going up or down? I'm going down. So this is negative infinity. Here, as x goes positive, you see, as x is getting bigger and bigger and bigger, what happens to my f of x? Am I going up or down? I'm going up. So this is positive infinity. Okay? Let's try and do the next one by yourself. Do this one and this one, and we're done for the lesson. Okay? So here, this will be even, but my leading coefficient is negative. Okay? And here, and we have the same setup in the green, right? As x goes negative infinity, as x goes positive infinity, where does my f of x go, right? What I want you to do is pause the video and try and figure this out right now. You see, as x goes negative infinity, am I going up or I'm going down? I'm going down. So my f of x values go to negative infinity. What about here? As x goes positive infinity, f of x goes negative infinity. Okay? Oh, that's a bad infinity sign. Okay? Let's look at the next one. This is degree is odd, and notice that this has which dance move? It has this dance move here. It's with the negative x to the 7th, right? So this leading coefficient here is negative. And now here, what's the end behavior? You have the same idea. X goes negative infinity, x goes positive infinity. Where does my f of x go? Okay. And I want you to, let's try and do this. You see here, look, we do this one first. As x goes negative infinity, right? So negative infinity is this way on the x. So as I go negative infinity, do I go up or I go down? I'm going up. So this is positive infinity. Here, as x goes positive infinity, as I'm going this way, am I going up or I'm going down? I'm going down to negative infinity. Okie dokie? Okie dokie. So here, this was very nice to have, and this we need to have in our notes. What I'd like you to do is, I'd like you to have this worksheet down, right? It says, for each graph, describe the end behavior, determine whether it represents an odd degree or an even degree function, and state the number of real zeros, okay? So you should have this worksheet and this one behind, right? We'll do one together, and then you could do the rest by yourself. So let's look at A, for example. A is describe the end behavior, right? So let's look at the first one. Here, describe the end behavior. The end behavior has to do with this idea of, hold on, where did my paper go? Ah, yeah, over here. It has to do with this. This is the end behavior, right? As x goes negative infinity. So let's see. Here, as x goes negative infinity, let's see, what happens to our f of x? My f of x goes where? You see, as x is going negative infinity, right? Notice it goes up, but then eventually it goes where? It goes down. So this is negative infinity. Here, if I have x approaches, here, let me zoom in a little bit. Okay, as x approaches positive infinity, right? You see, as x is going to positive infinity, my f of x, my graph will go down. So this is f of x goes negative infinity. And notice that this graph will match one of these graphs over here. Notice that this one is the same as even negative. So look at number 2. It says determine whether it represents an odd degree or an even degree polynomial. This polynomial must be even negative because the arrows at the end, you see these arrows are both going down. So here for this part here, the degree has to be even and the leading coefficient has to be negative. Okay? And look at the last part. It says state the number of real zeros. Well, how many zeros are there? 1 and 2. Remember, what does it mean to be a real zero? Where the graph intersects the x-axis. Okay? Happy face. This was a very simple, nice little lesson. What I'd like you to do is do B and then try and do 4A and 4B by yourself. Okie dokie. I'll see you.